In order to explain the failure theories, first we need to define what failure means. Failure could mean different things for different materials. In the context of mechanical design, most materials can be categorized into two groups: ductile and brittle materials. The distinction between ductile and brittle materials is based on the amount of materials strain at fracture. The strain, epsilon, is defined as the ratio of the material's elongation to its original length. If material's strain at fracture is larger than 5%, the material is considered ductile, and if it is less than 5%, it is considered brittle. Examples of ductile materials include steel, aluminum, and copper. Examples of brittle materials include cast iron, glass, and concrete. Now we can look at the mechanisms of failure for these materials. Ductile materials failure is defined as yielding, which means the component has become permanently distorted, thus ruining its geometry and losing its functionality. This is indicated by Y on the stress-strain diagram of a tensile test. For brittle materials, failure is defined as fracture, in which a component has separated into two or more pieces. Unlike ductile materials that go through a gradual and significant deformation before fracture, brittle materials fracture is fast and often without any visible warnings. This failure mode for brittle materials is shown by F on the stress-strain diagram. A good way to imagine the difference between the fracture of ductile and brittle materials is to think of a ductile material as a chocolate bar. It deforms a lot before fracturing. And a similar analogy for brittle materials is spaghetti pieces. They fracture quickly with negligible deformation.